In this video of FreeCAD series, so far we have covered around 49 videos where we started from very basics to Sketcher, and then now we are in part modeling environment. And so far we have not started any exercise, and there was a reason behind that. I wanted to introduce various concepts and basics of FreeCAD. Finally, time now came to also practice or create exercises. Hey there everyone, welcome back again to Engineering Pritam, and in this video is our first exercise where I will take measurement of this part and then we will try to replicate this stand which is of my Thunderbolt enclosure in FreeCAD. Okay, and that's how over the period of time we will understand the different manufacturing process, and then we will try to build or design our part based on the kind of manufacturing process we need to follow, of course by understanding their constraints. Alright, since so far we only have covered pad and pocket, so I'm going to use Sketcher, pad and pocket to create this geometry. Alright, so I'm going to start making this geometry first of all by analyzing the shape of it. So here what we see, it is a rounded square shaped geometry, and of course this is thin cell, and then there are cutouts in all four area. Apart from that, if I talk about the chamfer, there is little bit of roundness available all across, which could be of 0.2 mm. So that also can be added to our design. Let's now talk about inspection, and let me inspect this part. Alright, I am facing a little bit of difficulty here to set up my camera, but I will try my best to show you everything. Okay, so let's start measuring this part, and right now here I have got this vernier caliper, but I would say it is not mandatory. You can also use, let's say, scale to measure this part. Okay, and of course the accuracy of the part will be kind of dependent on the instrument that you are using. Let's start with the thickness of this part, which is thickness all around same, and there we go. Here what we see is this is 2.45 mm thick, as we can see. Let me also check it somewhere else, and here what we see is around 2.8 mm, and the reason why we are seeing 2.8 is because of this added grill. If I check the thickness back again where there is no grill, it should be the same. So here we go, it is 2.4. Alright, so now we know the thickness of this part, and since this is 2.8, so we can also calculate the thickness of the grill, which will be 2.8 minus 2.4 or 2.45, which is 2.8 minus thickness of this part, which is coming in between 2.4 and 2.5. If we consider the thickness as 2.4, then in that case the thickness of the grill will be 0.4. Now let's also see the width of this shape. So again, I'm gonna try to get the approximate figure here. So in this case, when I am doing flat to flat jaw measurement, it is exactly 15 mm. So that's really nice, like how precise this part is built. So 15 mm is the part thickness, and let me also see how much it is in this portion. So here also I would say is 15, or maybe it is going plus 0.1. Here also 15, and there we go. So it is complete 15. So sometimes the value may change based on the way you are measuring. So it is very important to measure the parts in a correct way, especially if the parts are precise metal components. Alright, so now we have got the thickness or width of it, which is 15 mm. Now let's talk about the next step, which is understanding these slots. So seems like these all four slots are almost same, which can be verified using external jaw of vernier caliper. So I'm gonna make it a little bit loose also. If I try to see how much it is. So this is coming around 92.5. So let me see this side is also same or not. And yep, this one is also 92.5. Of course there will be certain things here and there based on what kind of precision part it is. So I mean, by seeing this deviation of 500 micron. Okay, all right, so here what we can see again, it is almost same. So now we know the length of this slot, which is 92.5. Let me again go through, it is 5 or something else. Yep, 92.5. And let's also check the width of it. So width here what we see is 9.1 mm. Let me again check. Oh yeah, it is 9.1 mm. Okay. So now we know the length of this slot, width of this, thickness of this entire enclosure, closure support, and thickness of the mesh. Now the next thing I'm gonna do is I'm going to plot the same geometry in FreeCAD. So without further ado, let's now jump into our computer screen. Okay, so now we are in our computer screen and I am going to build the same enclosure part in FreeCAD. For that, first of all, let's quickly launch the FreeCAD. And there we go. From here, I'm gonna go part design and let's click on parametric part. Now let's go here on the top and click on sketcher. I can select here XY plane. Let's start plotting the sketch. And when we talk about the overall width of it, so it is coming to be 126.7. Let me also check from another side. And this side also it is quite precise, which is coming to be 126.7. Now let me draw this a 126.7 using a rounded rectangle. Let's plot this and now probably I can set it up. So let's use this particular dimensional constraint. And I am right now not perfectly aware of how much is the radius. So I can put some sample numbers, and since this was a complete square, so I'm going to select this particular constraint that's going to make this look better. Now I'm gonna also add some dimensional constraint to make this geometry at center. Now one more is needed to also control the x-axis movement, so let me also take this. Alright, so as we are aware of that the size of this is 126.8, so let me quickly put this value as 126.8. Now it looks like this. Let's also change this value to half of 126.8, and probably here we can put the relationship. So first of all, let me select this. So in order for expression to work, let me quickly set up the name of it. For that, let's make double click on it, and then here I'm gonna say rectangle length. And there we go. Now before we hit OK, please make sure that you see this message which is constraint name available for expression, which kind of shows that this name is available to use. Now I'm gonna click OK. Now let's select this 62 dimension, and instead of putting the hard value, I went to expression editor. Now I'm gonna write constraints, then dot rectangle length divided by 2. And then we can also see the value coming to be this much, which I would say is quite good, because else you need to manually change all these values and need to recalculate everything by yourself. So in this way, we are actually improving our productivity and efficiency, making the design smart. Now let's do similar style with this one as well. I'm gonna make double click on this value, and then again in expression editor, same, I'm gonna put constraint dot rect length divided by 2. Now click OK. Now our model is almost constrained, I would say. And then these dimensions are just the driven dimension. And all we need to do is we need to control one dimension, which is this one. And let's say I would like to make it 150. There we go. Everything here got automatically changed by itself. We can also change the value of radius if we want to set up some kind of relation between the length and radius value. So let me actually do that. So here we have got 5. Instead of 5, I'm gonna write constraint dot rect length, and then I'm gonna say divided by 15, which translates the radius value to 10 at this size, which I think is kind of proportional. Now if I again go back and make this 126.8 and let's hit OK, you can see everything changed, and this value now became the following. Now let me select the profile here, and I am going to use this offset geometry. And there you go, you can see the preview of it. So the thickness was around 2.5, so let's put 2.5, and there you go. Now let's click close. Now we have our sketch ready. Let's pad this thing, and as we know, the height of the part was 15 mm, so I'm gonna put 15, and let's make it symmetric to the plane. Now let's click OK. Now the next thing here we need to do is we need to add pocket. And in order to add pocket, simply select the surface and then click on sketcher. Now again we are in sketching mode, so let's quickly create this slot here and let's constrain it. So I'm gonna say it has 4.5. Now let's make it symmetric. For that, you need to select the y-axis, and then you need to select these 2 points, this point and this point. Now I'm gonna click on symmetric. And here seems the entire thing is over constrained. So let me actually delete these constraint, the center constraint. And there you go. Now let me add dimension here. And here you can see it's how you can control it. And probably I also need to add one more here to control the radius. Or I would say in this way you can further control the width as well. So the value for this was 92.8. I'm gonna put 92.8 and let's hit OK. Now of course we need to bring this in center. So I'm gonna use the coincident constraint. Now we need to bring this in center as well. For that I'm gonna select this line and then I am going to click on coincident constraint. For that I need to select the line, then the center, then I'm gonna hit coincident. And there you go. Now let's click close, and now I am going to click on pocket. Now let me select the sketch and let's click on pocket. Now let me also delete this line segment that we have created in starting, which by the way was created mistakenly. Now let me put equal constraint here, and now I can close this. Let me select the sketch and now click on pocket, and there you go. Here we can see the pocket is created, and then I have used through all because the pocket was in all these 4 sizes. So in this way guys, we have created these slots. Now here also I'm gonna do same pocket. I can also do up to face, and then I can select this face. So in this way guys, finally we have formed the shape that we wanted to, and we just created this entire profile using 2 3D command, which is pad and pocket, that we have understood. So look for the shape and think of like if you can create that shape using the tool that we have covered so far. So we created this entire shape using only 2 tools that we have covered so far, and I would also suggest you to try creating this by yourself. And that's wrap up this video. Hope that you find this video helpful and informational and learned like how we can use even some of the basic tools to create a real world thing that I showed you in starting. Make sure you subscribe to Engineering Pritam to follow complete FreeCAD series, and I will see you soon with one such another video. Till then, you take care and bye bye.